So somebody asked about 7.4, so let me pull that up right now. Because I have that in my downloads. Bear with me for a minute here.
No worries.
But like I said, if you're stuck with that, it's most likely because looks like it's somebody's Math 104 college textbook. No. Let me find it in my email. Because you only are given two values in that problem. That in 7.4, number 4, you only have two values, and they ask you about the standard deviation. And so actually as a concept that goes back to chapter 3, page, I think I remember it being page 139 in your textbook, but let me look at it for you here. But the range rule of thumb essentially says that that if you only have two values, you take the range, you divide it by 4, and you get the standard deviation. That's essentially what that one says. But 7.4 number 4, let me see which one. Is that the carbohydrates one, or is that the one after it? The U.S. insurers problem, right?
Yeah, I'm trying to pull it up too, but not
Let
loading.
me pull down the homework, because the thing is, I have the solutions, but my numbers don't match because they were based on giving you all of the odds, and she didn't. So let me pull that down as well. So let me see, because I don't have the 7.4 homework. Welcome, Alejandra. Do you have a question about something while I'm pulling it down so I can?
Oh, I'm working on my exam, but I'm also hearing in whatever other
That's
questions students may have.
no
Thank
problem. We can do that too. She usually doesn't have a question about the range rule of thumb, but I'm not precluding it in any way. Let me go in and get the homework for that section. Canvas 7.4. Inbox. No. That's what we wanted this here. So let me see. Modules, assignments, and oops. Okay, now we're there. Let's see. 7.4. Let me check and see what she gave you. She gave you okay, let's go. There it is. Number 4. Okay. Yeah, number 3 was the carbohydrates problem. So number 4. Yeah, okay, this does involve the range rule of thumb. I thought it did, and it does. So what we're going to do here, we know how to get the confidence interval already with the formula, and I will review that for you as well. But here, there's a nuance in this, because, as I said, you're only given two values. It says the cost of knee replacement surgery for US insurers range from 17,627 to 25,462. Estimate the population variance and standard deviation in cost with 98% confidence based on a random sample of 10 persons who've had this surgery. Now, this piece of this, the other part to this is a little bit sneaky because technically it's a 4-part question. Okay, it doesn't look like it, but it is. From here where it says the cost of knee replacement surgery, US insurers, all the way into this period. That's actually 2 questions, okay? Because it's asking you to estimate the population variance. So you're going to get the confidence interval for the variance. Then you're going to get the confidence interval for the standard deviation for the US insurers, okay? Now, the question for most students is, okay, if we go back to the formula for the confidence interval for a variance, we have something like this. It's n minus 1 times s squared over, remember, these look like they're reversed, but remember, chi-square right is larger than chi-square left. And so this left is not actually left, it's the right, which I didn't do. I said it, but I didn't write it. So let me erase this, because this is going to be wrong. This is going to be chi-square right. So this chi-square right is going to be larger. So chi-square right here. And then this is going to be, this should be less than or equal to, just less than, sorry, less than. Then we have chi squared in the middle. So this is going to be chi squared here. I mean, sorry, sigma squared. And then you have n minus 1s squared over chi squared left. Now, the problem is not n. We know n is 10. We can get chi square left and right with the calculator. The problem is s, and that requires the range rule of thumb from chapter 3. So you have n minus 1. This is s squared. And this is chi left, which I'm writing as x because I'm on Zoom. So that's your formula. The range rule of thumb here goes back, as I said, to something else. So let me show you that now. I'm going to pull up the textbook. Here, I'm going to stop sharing temporarily and pull up the textbook and show you that. So, let's see. We're going to go to desktop and we're going to go. Now, if I share the screen with you, and I say, okay, here's my book. Now, if I go here and say that we're going to go to, I believe that it is page, we're almost there. Let me see, this is page 130, we're getting closer. Get to that here. Am I wrong? Here it is. It says, the range rule of thumb can be used to approximate the standard deviation. The range can be used to approximate the standard deviation. The approximation is called the range rule of thumb. It's the range divided by 4. In other words, if the range is divided by 4, an approximate value for the standard deviation is obtained. Okay. The range rule of thumb, I'm reading in the second paragraph here. The range rule of thumb can be used to estimate the largest and smallest data values of a data set. Okay. So you can also use it to approximate the smallest and largest, but if you only have 2 values, you divide the range by 4. So what you want to do with this problem, that is page 139 in your textbook, by the way. What you want to do with this problem about the knee replacements is you want to take 25,462 and subtract 17,627. Divide the difference by 4 and use that as x for this first piece of the confidence intervals. So then you're going to do the same thing down here for retail costs. So you're actually going to have, this problem is going to have 4 intervals in it. It's going to have 4 intervals because you need to do one for the standard deviation and one for the variance for each of those situations. So I'm going to see if I can share the screen here so you can see what I'm talking about. So here on the screen is your insurers. So you have 25,462 minus 17,627. That's 1,958.75. Your formula's in the middle of the screen. For those of you who are using the calculator, these are your calculator values here. And your calculator procedures. And if you'll notice, she has a confidence interval here. So it's $1,593 and I'm sure that it's, and then that sigma squared. So that's for your variance. She square rooted it and got the standard deviation. So those 2 answers for the first part. And then she does a similar procedure for the retail piece. Doesn't show quite as many steps, but doesn't show the calculator procedures, but does show all of the math here. Does that help, Jay?
Yes, it does.
Okay.
I couldn't figure out how to find the S, but now I do.
Yeah, that's kind of the trick there is to use that range rule of thumb thing. So, anything I can help you with, Alejandra?
Should I send you a
Are you
screenshot of-
looking, are you
Yeah.
looking for answer? Okay, what I can do is I wasn't sure how far people had gotten with the exam. I'm not sure how
I'm
long it's
only
been.
on number 2.
Yeah, no, I didn't know. And that's why I figured, well, let me see. Okay, let me just bring this up so I can bring this down and pause. So if you're looking at the exam and you're looking at problem with the dice, this is the even sums. I'll show you the problem in a minute here, but it refers to the sample space for 2 dice. You can find this on the slides for section 4.1. If you go back, you can also find it in your textbook on the page that I have on the screen. There are 36 outcomes in the sample space for 2 dice. However, the problem says that you're only doing the even sums. Even sums, remember, are numbers that are divisible by 2. So 2, 4, and 6. Okay. Those are those sums. Now, if you're doing sums, remember the sums go from 2 to 12. So you're only counting the even sums between 2 and 12. Okay. And if you go through this list, this sample space here, you're not going to have 36 outcomes that are even sums. For example, 1, 1 gives you a sum of 2 that's even. 1, 2 is an odd sum. 1 plus 2 is 3, so you don't consider that. 1 plus 3 is 4, that's even, so you consider that. But 1, 4 gives you a sum of 5, you don't consider that. Go through the sample space and figure out how many of your outcomes are even, and use that number as the denominator of your probability. Let me show you the problem that we're. So if you're having an issue with the first one, as I said, keep in mind that the sample space for 2 dice does have 36 outcomes. If you need to go back and look at the sample space for 2 dice, you'll find this in your textbook in section 4.1. You'll also find it in the slides, but the sample space for 2 dice is in section 4.1. Okay, so you can look there if you need more help. Keep in mind though that you're only using the even sums of your elements, not all 36 outcomes. So the size of your sample space is not 36 here. You have to go through and count how many sums are even. And you should use that number that you find there. You said,
So 7.3 on number 8 on the second part, it says p hat equals 0.50 and then q hat equals 1 minus p hat equals. So are we using this as like for any problem that says if no estimate of the sample portion is available, I would go with those numbers?
that's correct. So whenever you're doing a confidence interval for a proportion and you don't have a percentage given from a prior study, you always use 0.5 for your percent.
Okay.
So that's where that came from. Okay.
Okay. Give me a second. Okay, dokie. Okay, thank you, Shauna.
You're welcome.
Okay, I'm gonna download and then start working on it, and then I'll log back in.
Okay, before we get to 10.2, I want to show you something for those of you who are watching us later or watching us remotely. Let me click in here and show you something. Your homework for this module, the homework that she's collecting on the 9th with your exam, covers 7.3, 7.4, and 10.2. It doesn't cover 8.1, even though 8 is part of this module technically for this week, okay? Don't work on 8.1 until after you finish your exam. Do work on it, but don't work on it until after you finish your exam. There is support for the introduction to hypothesis testing. The beginning of this chapter is really important. Also, something else that I should tell you. This weekend, November 10th, Veterans Day, November 10th and 11th, the campus will be closed those days. So we won't have our regular embedded tutoring this Friday because it's a holiday. The campus is closed and I'm contractually obligated not to provide services on those days. So the next tutoring session that we'll have will be the following week. Okay, so just know that, but don't panic if you're having an issue with the 8.1.
Okay.
Don't work on that because you've got more than enough to work on here. So somebody's asking for an additional problem from 10.2. If you haven't seen the video yet, you can look at the examples there. But here is the homework. This is our meal costs. It says a student who waits on tables at a restaurant recorded the cost of meals and the tip left by single diners. Anytime you see a problem like this, and Professor McDowell has done it, you can safely assume that your top line is your X and your bottom line is your Y. That's typically just a convention of hers, and it's
Okay.
one that she maintains. So your data is going across the page. Keep in mind that in the calculator, it will go down. Before we can answer any of the questions that we're supposed to, I'm going to share my calculator at this time. And I'm going to clear the screen. And I'm going to go to stat so I can enter my data into the calculator. So now go to stat, go to edit, just like we normally would. This data was old, so I'm going to go ahead and erase it from my screen, my list. I'm going to put the X data in L1, the Y data in L2. I'm reading these off screen, but these are the same that I used earlier. 4.75, 6.84, 12.52, 20.42, 42, oops, 20.42 and 8.97. Then we have 50 cents. You can just enter the decimal. You don't need the leading 0.9 or 90 cents. $1.50 and $3 and $1. Now, I'm going to go ahead and the first thing that it asks us to do, let me go back to oops, stop sharing. The first thing that the problem asks us to do is to do the scatter plot of the table above on your graphing calculator. So we're going to shut the calculator, and to do your scatter plot, you're going to go your plot is above your y equals key up here. So you're going to go to second stat plot,
Second.
turn your plot on. So right now, whoops, my apologies. Second
Sorry, you
stat
said second and plot.
second and then y equals right here.
Y
You should
equals?
get a
Okay.
screen that looks like plot 1, plot 2. If your
Okay.
plot is off, make sure you turn it on by hitting the enter key. Hit the enter key.
Okay. My whitelist says L1. How do I
No,
change
it's so are you seeing this screen?
Yes, but my whitelist is okay, but my whitelist says L1. So do I put second and
So what you're gonna do is, yeah, if it says something different, let me make it say something different for the sake of this example. So if my X list said L5, for example, and I wanted it to say L1, right? Then what I'm gonna do is make sure your cursor is on your L for whatever that is. Now your L's are above your numbers 1 through 6.
yes.
So I'm gonna hit the second key and I'm gonna say L1 for that. Now, if your L1 is fine, but your L2 isn't, your Y list isn't, go to second and then just hit the number 2.
Okay,
So your
perfect. Now it's good.
screen looks like this.
Yes.
Are we
Okay.
good now?
Yes.
Again, Professor Nickdell said that she prefers the first mark only because it's the largest and easiest to see. Okay. Before you graph, a couple of things. Make sure that your y equals, hit y equals right now. Make sure that your y equals key doesn't have, and I'm not sure why it did that. Make sure that your y equals doesn't have an equation in it.
Okay, let me go back.
Okay.
An
Make sure
equation
that
here.
your y here doesn't have an equation in there, because otherwise it'll graph that for you. So you don't want to do that. Second stat plot, make sure, again, I need to turn this on, do this again, because that's just how my emulator works. You'll be fine. Okay, enter here, we do all that. Now, the other thing is your window setting. You can set your window manually, but you don't have to. The easiest way for you to address that is with Zoom. And for
Zoom?
me, it's 9 on my menu. You should see something that says Zoom stat, this one.
Zoom stat number 6.
It might be number 10, it might be number 8, depending on how many options you have, but you're looking for that. My Zoom stat looks like what you see on the screen.
Zoom stat, right?
Zoom stat. And once you hit Zoom stat, it will show you the scatter plot.
Oh, okay, now I did it.
Now,
Perfect.
the other thing that you will need for, is gonna ask you for the regression line. I just want to point out something here. That
Yes.
if you go to your window, click window,
Oh,
it will give you a window here. This is the window that my calculator used. Yours might use a slightly different window depending on how it calculates the approximation.
regression line. Regression line is the R, right?
No, regression line is the actual line. R is
Okay.
called the regression coefficient of linear regression. The line itself is the actual line. We're going to get that in a minute. I just
Okay.
want to point out that the window here, she's going to ask you for the window on the exam. This is where you get it from.
And then we
Okay.
plot those numbers into the example. Okay, got you.
Well, you don't plot them, you write them where it says window.
The
Okay.
numbers.
But yes, and then you approximate where your dots are located, because remember, you know where your dots are from
Mhm.
the data, right? You know where they are from the data points, so you plot them accordingly. Now, to get your regression equation, okay, we're going to quit this window, so second quit, we're going to go
Second.
to stat.
That.
Then we have some menus across the top, you see? Normally
Mhm.
we're on the edit screen, we're gonna go to calc here. I'm gonna go to the
Okay.
middle menu, calc, and you're gonna look for an option. There's gonna be 2 of them. There's gonna be linear regression AX plus B and linear regression A plus BX. We want the one with the A first. The AX plus B. We want this AX first. So we want number 4.
Okay. Number.
And then the setup is primarily the same. L1, L2,
Okay.
L1, L2,
Okay.
your frequency list. Don't worry about storing your regression equation. We're going to calculate this. Now, you should have 4 values on your screen.
Yes.
Okay. If you do not have 4 values on your screen, go back and look at the video where Professor Nickdell explains this. You have to go into the catalog on your screen. I also explain this in a video that I did. If you go into the video on I believe it's from 7.4, I also did some calculations for that. And so that is the other piece of that. So that's how you get R. What you want to write down from this screen is you're rounding it to 4 decimal places, remember. So you want to write down A rounded to 4 decimal places. So 0.1569. A is 0.1569, and I'll put this up momentarily, but I'm writing it off screen. B is negative 0.2992. negative 0.2992, and R is 0.9911. Okay,
Okay.
so now what we're going to do, the reason I told you to write those down is because we're going to go into your y equals, and this is the other reason why I had you erase your equation before. Go into the y equals key,
Okay.
and on the y equals screen, notice your plot is still highlighted, meaning that your statistical plot, which was your regression, your scatter plot, was still graphed. We're going to put in the equation. So we're going to get 0.1569, and remember that goes in front of our x. You're going to use this x next to the alpha key with the x, t, theta, this thing in the middle that looks like a circle with a line through it, x, t, theta, and n, 0.1569x, and your b is negative, so make sure here that you use the minus. The big minus, not the toggle minus down by the enter key, but the minus next to 6. Use the big minus because you're actually subtracting this time. And you get, yes, 0.2992. That's my equation. Now, if you hit graph again, you'll see the regression line.
Once you put it in, you just press graph right now?
Yes. Press graph,
Okay. Oh, nice.
and you should see the regression line. When you
Okay.
put this on your paper, okay? When you put this on your paper, she's going to give you a grid. She's not going to have pre-formed numbers on that grid. So use the scale that's appropriate for your data. You can use the window setting to help you with that. But remember, you're graphing the actual points that were in your data set. So when you do this, you're actually graphing these points. X is 4.75, Y is 0.5. Remember, each pair, so each column in this case, corresponds to 1 point. So for this example, you'll have 5 points listed.
Gotcha.
Okay.
Okay.
Once you approximate that, you know what your regression equation is, because guess what? We just got it. We got the regression equation right here. Oops. We got the regression equation right here. 0.1569x minus 0.2992. Okay. So it now says, let's follow along with what the actual homework tells us. So here, the homework says, make a scatter plot of the table. We did that. Find the linear regression equation in the form y equals mx plus b. What is R, the correlation coefficient? So you're going to state what R is as part of your regression equation. So for part B here, what you would write for part B, I'll put it in the, let me write it. So for part B, you have part B, you have y equals 0.1569x minus 0.2992. And you also know that R is equal to 0.9911.
Gotcha.
So that's for part B. Graph
Okay.
the linear regression equation. So A, you graph the scatter plot. A and C should be on the same grid. Okay,
Okay.
so you're gonna graph your scatter plot. Then for C, you're gonna go back to the graph and put your line on top of it, which is just like what you see on your calculator. What you're trying to do is duplicate what your calculator is giving you. We're not going to
Gotcha.
be too picky about, you know, how close you are or whatever. What we look for is the window and the scale of your drawing. So, but we're not being extra picky, like if it was 3.85 and you plotted, you know, something that looks closer to 3.5, we're not gonna have a fit over it, but it should look like your calculator looks, because the way she checks these is with the window and by putting your window into her calculator. So just know that's part of that. Okay. The last piece of this says that asks a question, and it says, if the next diner orders a meal costing $10.50, how much tip should the waiter expect to receive? Well, when you write this regression equation here, you can either use it to solve for the X or the Y, right? In this case, it says the next diner orders a meal costing $10.50. Meal cost, as I told you, is your X. So you're going to assume for letter D rather, that your X, another way of saying this is find Y
Why?
when X is $10.50. That's what that essentially says. Find the Y value when X is $10.50. So what I'm going to do here is I'm going to go back to my calculator
Okay.
and I'm going to say, I'm going to quit from my screen here, and I'm going to say that I'm looking at, I have 0.1569, and I'm
Parentheses?
multiplying it by, yeah, or the star, either way. But I'm gonna multiply that by $10.50,
Plus
and then I'm going to subtract my B, which is 0.2992.
When I write it right now that I put on the calculator and I put y equals and then the rest and then y when I solve is y equal.
It would be Y equals, And in this case, since it's money, you're going to round it, and it's going to be 1.35. It's gonna be $1.35 is your cost.
3, 4, 8, 5, 5. Gotcha.
So somebody asked about decimal places, and I get this question a lot, so I'm going to bring it up here.
I
Let me
think I've
bring it-
asked that before too.
well,
You
it's
have.
then it's worth going over, and now it'll be on video, so everybody can rewatch it as many times as I address this in my videos a lot as well. So let me give you just a second of background here. Whenever let me do this first. You know that not every number that we write is a whole number, right? So I can write the number 1, or I can write the number 2, or I can write the number 25, right? And those don't have decimals in them, visible decimals, right? But I can write something like, you go to the store and you see something like this. You see a number with a decimal point, and maybe it doesn't have to be zeros. Maybe you see you spent this amount at the store with a dollar sign, or you go to the gas station and you see this, right? This
Yes.
little element, this dot that you see, we call that a decimal point, okay? Or just a decimal for short. We use decimal, the word decimal, to mean different things. So if I talk about a decimal, I could be talking about a decimal number, meaning a number with a visible decimal point in it. I could be talking about that. Or I could just be talking about the decimal point itself. Sometimes instead of saying decimal point, which refers to the dot, the decimal point is the actual dot that you see there. But sometimes we drop this decimal point and we can call this just a decimal. So sometimes what we mean when we use decimal is decimal point. If I say 1.34 and I refer to this as this is a decimal, what I mean here is it's a decimal number. Okay, so just for the sake of clarity. Now, if I talk about decimal places, okay, rounding is a different story. I've talked about rounding before, but decimal places always mean numbers to the right, and I'm going to put that in caps. I'm not shouting, I'm just emphasizing. Numbers to the right of the decimal point. That's always what decimal places mean. Okay?
Okay.
Decimal places are to the right or after the decimal. Okay? So in this case, if I had a number like 1.4578, how many decimal places does that have?
4.
This has 4 decimal places in it, okay? This has 4 decimal places inside. Now, if I had a number like 1.24, how many decimal places does this have?
2.
This has 2. Now, here's the thing. This is where your rounding rules come in, okay?
Yeah.
If you're going to round anything, whether it's a number with a decimal point or what we call a whole number up here that doesn't have a visible decimal point in it. By the way, as you might be able to tell, because this is another thing that comes up sometimes for people, is here This is what we call on the left. This is what we call a whole number, meaning that it doesn't have a fractional part to it. It doesn't have a decimal portion. Every whole number here, every whole number has a hidden decimal point all the time.
Okay.
And you know this if you go to the store. You go to the store, the clerk says you buy something and they say, you owe me $2. You give them $2, you probably think that it's this $2 on the left. You get the receipt and it says this. It says 2.0 or 2.00. Or another place you see this sometimes is if you fill out time cards at work and they give you hours, right? You work exactly 8 hours, you might see 8.0 or 8.00 on your time card. There's always a hidden decimal point after these numbers. We don't usually write it unless it's necessary, unless there's a fractional part to it. It's not necessary with a whole number. Okay, so just something for you to consider there. Now about rounding, because this is another thing that I get asked a lot, and it doesn't matter what class I'm in. So we talked about what decimal places means briefly. Let's say I have this, okay? Now this has 4 decimal places in our answer, okay? If I want to round to, let's say 3 decimal places or 3 decimals, okay? 3 decimal places, okay? If I want to round and I want to round to 3, then that means what I have to do is I have to come over here. I have to go to the decimal point right here, and I have to count 3 decimal places. 1, 2, 3. I want to round where the 4 is, right here. Meaning that I want my answer to contain 3 places after the decimal. But here's the thing. Anytime you want to round to whatever it says, you have to take your answer to 1 more place. So if it says round to 3, then you have to take it to 4. If you have your calculator's float set on a certain number of decimal places, it will do this for you. But I'm assuming that you maybe don't, or you're looking at a number that doesn't have that. Round to 3 decimal places. So this number has 4 decimal places. I want it to round to 3. So I'm going to look at the number behind me, to the right of me, which is where this 5 is. And I'm going to, the rule that I use, generally there's an exception, and I'll show you that too. But the rule is the same. You look at the digit, meaning the individual number. You look at the digit, the individual number, in the next place to the right. And you ask yourself a question. Is this number that you're looking at 5 or larger? Okay, that's going to be a yes or no question. Either it's 5, 6, 7, 8, or 9, or it's not. Is this number 5 or larger? If you answer yes, then you change the number in the place before.
Got it.
If you answer no, and also you change the number in the place before, and then drop the rest. Okay, now there's an exception. I'm going to come back to that. There's one time when we change 2 digits, but normally we only change 1 digit. If you answer no, then you keep the number. Keep the
Gotcha.
number in the place before. Keep the number in the place before. And drop the rest. Now, the
Perfect.
exception to that, and this always messes people up. What if I give you something like this? 1.2999. And I want you to round this to 3 decimal places. Okay. There's a 9 here. Okay. And I want to round this to 3 decimal places. Okay. Well, if I round to 3 decimal places, all right, then what I'm going to do is I'm going to have 1 point. Now, my question here is, what happens here? I've got a bunch of 9s, right? So what's going to happen to this 9, right? I know I need a 9 here, but I've got a 9 behind it. So I'm looking at this here, right? I'm looking at this 9 here. Now I have to, that's where I want to round, but I have to look at this 9 behind me. Now, this is a 9 behind me, and I have to, it says, I change the number. So I take it up by 1. Here's the problem. If I take 9 up by 1, I get a 10. And there's no room for a 10, right? So what has to happen here is I actually end up changing 2 digits. Okay, this is 299. This is going to become not 299, 29, but I need a 10. So what I'm going to end up doing is I'm going to end up changing 2 of these digits, and I'm going to have 1 point. This is going to be 299 is going to go to 300. Now, do I need the trailing zeros? Not for the equivalence of the answer, but I need the trailing zeros because it specifically says round to 3. Okay, so if you have consecutive 9s in the place where you're trying to round and the place after it, if you have consecutive 9s, so 9s that are next to each other, if you have consecutive 9s, if you have consecutive 9s, then 2 places will change digits.
Thank you, Shauna.
Okay, that's the issue, and I don't want you to feel bad because, as I said,